students. In the previous class, we have discussed about displacement, distance, speed, velocity, etc. And you have a good idea about all these terms. Before we begin this class, write down a small question. What is the difference between speed and velocity? You can pause the video and write down the differences between speed and velocity. As you can see, what is speed? It is a quantity that depends only on the magnitude. What is magnitude? The number. Velocity is a quantity that depends both on the magnitude as well as the direction. The basic difference between the two is that speed is a quantity that depends only on the magnitude, whereas velocity is a quantity that depends both on magnitude as well as direction. I asked you to note about these two because we need this in the further discussion that we are going to do. Look at this particular table. Here there are two objects A and B which are traveling from 9:30 and observing the positions of A and B after each 15 minutes. If we look at the table, we can see that after each 15 minutes, object A is covering equal intervals of 10 meters, whereas the object B is changing the distance that it is covering at different intervals of time. So what can you say about the motion of the two objects? Object A, it is having uniform motion, is it? Whereas the object B is having non-uniform motion. There is a change in the velocity of the object B, and we term that particular quantity as acceleration. So that is a new term that you are going to learn, which may be defined as the measure of change in the velocity of an object per unit time. So whenever there is a change in the velocity of an object, we can say that the object is having an acceleration. If we write the definition in terms of an equation, we get acceleration is equal to change in velocity by the time taken. If the velocity of an object changes from an initial value of u to a final value of v in time t, then acceleration A can be given by A is equal to v minus u by t. Here it is to be clearly noted that the v, which is the final value, minus u is the initial value, and t is the time taken for that change from u to v. As it is a physical quantity, you know that it should be having a unit. Here we are taking in the numerator the difference of two velocities, which means that is also a velocity, and in the denominator we are having time. So here unit of velocity is meter per second and unit of time is second. So what will happen to the unit of acceleration? It will be meter per second square. The SI unit of acceleration is meter per second square. Now you learn about what is acceleration, and we shall discuss about the types of acceleration using the previous equation. The equation is A is equal to v minus u by t. Now let us assume that an object is initially coming from rest and moving with some certain velocity. So what can you say about the relation between v and u? V will be greater than u as the object is starting from rest and attaining certain velocity. So the acceleration will be having a positive value, and that is called positive acceleration. In the second case, if you are considering an object which is moving with certain velocity and after some time it comes to rest, in this case what happens to v and u? Initially it is having certain velocity, finally it is coming to rest. So the value of v here will be 0, but it is having a initial value u. If you substitute in this particular equation, we get 0 minus u by t. So minus u by t will be the result. In there we get a negative value, and that is called a negative acceleration. The other names for negative acceleration are deceleration or retardation. The second type is negative acceleration. We have discussed about a case when there is a change in velocity. If suppose the velocities are same, what will happen to the value v minus u? As it is the same, they turn out to be 0. Acceleration will be 0. That is the third type of acceleration, or 0 acceleration. We can say that as the values v and u are the same, the object is undergoing uniform motion. So if an object is undergoing uniform motion, the acceleration of the object will be 0. Let us discuss more about acceleration. In the beginning, I have asked you to write the difference between speed and velocity, and the main difference I wanted was in speed there is only magnitude, whereas in velocity we have both magnitude as well as direction. Velocity is a combination of speed as well as direction, and you know that whenever there is a change in velocity there will be acceleration. Velocity changes if speed alone changes. That means there is no change in the direction of motion, then the velocity can change. In the second case, there is change in the direction alone. The magnitude of velocity is not changing, and hence there can be acceleration as the direction is changing. In the final case, both speed as well as the direction can change, and that outcome will be a change in the acceleration. Now let us do a problem based on the concept of acceleration. Starting from rest, Rahul paddles his bicycle to attain a velocity of 6 meters per second in 30 seconds. Then he applies brakes such that his velocity decreases to 4 meters per second in 5 seconds. Find his acceleration in both the cases. This is the question. Now, before we go into the problem, there are certain things that you have to keep in mind while doing the problem. First thing, you have to read the problem again and again until it is clear, and then according to the given data you have to write the terms. Here in the first case it is given that the he is starting from rest. So initial velocity is 0, and after 30 seconds his velocity is 6 meter per second. So that is the final velocity, and the time 30 seconds. What is the equation to find acceleration? A is equal to 6 minus 0 by 30. So what is the value? 1 by 5 meter per second square. That is the value of acceleration in the first case. Now, what is the second case? He is applying the brakes. The initial value of velocity is 6 meter per second, and final value of velocity is 4 meter per second, and the time taken is 5 seconds. Therefore, acceleration is equal to, not writing the equation again, final value minus initial value by the time taken. Here it is minus 2 by 5 meter per second square. Here we have obtained a value of 1 by 5, which is positive, and here the value is negative. Why? Its velocity is decreasing, and hence the acceleration is decreasing, negative value, and here the value is positive since the velocity is increasing. I hope it is clear. As we come to the end of the session, let us recollect all the things that we have learned today. First, we have discussed about the new concept of acceleration, the types of acceleration, the variation or the dependence of acceleration based on speed and direction, and later on we have solved a numerical. Here you have another numerical, you can solve it. It is to find the acceleration of the bus. Here they have given the initial and final values of velocity, and the time is also given. Can be solved easily.